Yeah. In this experiment, we are going to discuss about the common emitter configuration of a bipolar junction transistor input characteristics. What is the bipolar junction transistor? Once you have to see, in a bipolar junction transistor, like this, we made the bipolar junction transistor. In this bipolar junction transistor, one tag is there, that notch. Which terminal is nearer to the notch, that terminal we call it as a emitter terminal, right? The subsequent terminal is base, and then other terminal is collector terminal. So three terminals are there for transistor. One is emitter, another one is base, another one is collector. How we have to identify? By based on the notch we have to identify. Nearer to the notch, that is emitter, subsequent terminal is base, and next subsequent terminal is the collector terminal. Now what is our ultimate goal? Our aim is common emitter configuration, BJT, input characteristics. What are the input characteristics? We will see. What is the aim? To study the input characteristics of a bipolar junction transistor in common emitter configuration and calculate the input resistance. That input resistance we also call it as a input impedance also. Delta VBE by delta IB at a constant output voltage, that is the VCE. First, what are the operators we need? So we need the transistor, we need, right? So we have to take a resistance, resistors. One is 33K resistor, this is the 33K, and this one is 470 resistor. We are taking two resistors, we are taking one resistor I am giving to the input, one more resistor I am giving to the output. Clear? Now these are the patch cards, right? This one is the cutter to cut the wires. Now you are able to see what is the formula you have to see. The formula is input impedance is equal to delta VBE by delta IB at a constant voltage. How we have to identify this transistor is NPN transistor or PNP transistor? Whether it may be NPN transistor, that number is BC107. BC107 is the NPN transistor. BC557 or AC128 is the PNP transistor. Based on your number, you have to connect here, whether it may be NPN or PNP. First, you see the circuit diagram. This one is NPN transistor symbol, NPN transistor symbol. Here emitter is common to the input, emitter is common to the output. Now emitter is connected to the ground first. We have to connect the emitter is. Next, we have to take two batteries. We are taking two power supply 1 and power supply 2. These two power supplies you have to take. From the power supply 1 to 33K, you have to give first connection, power supply 1 to 33K, and subsequent another terminal you have to give to the IB, that is the microamps. This is the input current, positive terminal, negative terminal, and this one is going to give to the base of the transistor. So this is the base is made with positive, positive is connected to the positive, and negative is connected to the negative. Such type of biasing we call it as a forward biasing. Input we have to give to the forward bias. Always input you have to give the forward bias, right? So because it is a NPN transistor, 107 transistor, BC107 transistor. Now the output you are able to see, 470 resistor you have to keep here connected to 471 end, and another end you have to give to the another power supply positive and power supply negative. This is a N2 positive, this is the reverse bias. Reverse bias, output terminal you have to always connected into the reverse bias you have to collect. For input voltage purpose, we have to connect the VBE. For output voltage purpose, we have to connect the VCE in between the ground and collector. in between the ground and base you have to connect. Now based on this circuit diagram, we have to connect here. Once you have to see how we have to connect power supply positive. Power supply positive to 33K. This is the 33K. 33K resistor you have to keep like this. 33K resistor you have to keep. Now power supply positive, you able to give the 33K one end. Clear? 33K one end I am giving. Now the next end we are going to give, which one we are going to give according to the diagram. So milliammeter positive. The next end is going to give the milliammeter positive. The milliammeter negative, this milliammeter negative to the base. So what is the base? In the middle of the transistor, that is the base, because this is emitter, base, collector. So a base I am giving. Now you are able to see one jumper you have to take. This is the jumper. Uh, from emitter you give that ground directly. You have to connect it into the ground. Emitter I am giving it to the ground. Clear? Now collector terminal, where we have to take the collector. The 470 ohms resistance is there. This is the 470 ohms resistance I am giving into a collector. Clear? The 470 ohms resistance I am giving into the collector. The 470 ohms resistor another end you have to give to the power supply positive. Where we have to give? Power supply positive you have to give. Power supply positive. Clear? Power supply positive I am giving. Now the power supply negative you connected to the ground. Power supply negative is connected to the ground. Clear? Now, so this power supply also you have to connect it to the ground. Now you able to see how many grounds are there. You have to count it. So this one is ground, right? Emitter is ground, and another power supply also I am connecting into the ground. Now the voltmeter is there. So a voltmeter you have to take this voltmeter negative. You always connected into the ground. Voltmeter negative always connected into the ground. This is the horizontal connection. This connection is horizontal connection. This connection is vertical connection. That voltmeter positive. So for two wires you have to keep for voltmeter positive. What is our ultimate goal? We have to find the input characteristics of the transistor. For finding the input characteristics of the transistor, what we have to do? So first we have to set the VCE. VCE means output voltage we have to keep the constant, and input voltage and input current we are varying. First output voltage is output voltage I am taking the ground. So this output voltage positive terminal you are going to give to the which terminal we have to give? Wherever the collector is there, there you have to keep the output terminal of the output terminal. So you have to keep that one. So that output terminal you have to keep here, so that the voltmeter already is grounded, right? So now what we have to do? First we have to switch on the observations. We are going for the observations. First you have to roll out completely ground. You have to do first. You have to take, this is the input voltage VBE. This one is output voltage VCE. You have to keep. This is output voltage. This is input voltage VBE. Correct? This one is the input voltage. Now first you apply. How much you have to apply? For 0 volts you have to apply. VCE is 0. Which one we have to rotate? We have to rotate this power supply we have to rotate. So once you have to rotate it, so it is rotating. Now how much it is rotating? Once you have to see 0, 0.5, 1 we have to apply. First 0 you have to apply. Power supply VCE output voltage is 0. First you have to apply the output voltage is 0. After applying this output voltage 0, you never change this term. You never rotate it. Now you switch off, right? Now you have to take this positive terminal, you have to remove, right? Once I am removing the positive terminal, again I am going into the, so again I am going into the diagram. This VCE, now I have to apply in the place of VBE. Again I am applying the place of where we have to apply VBE. This positive terminal we are going to apply wherever is there, base is there, there you have to apply. So where it is base, so base is in between the terminal is there, so that terminal you have to take it as a base, that base you able to take, there you have to apply. Now you have to rotate this one. This is a VBE now, input voltage versus out input current IB. So that one you have to see here. First you apply the 0 volts, you have to apply here, 0 volts you have to apply here. How much current is getting, so that microamps you have to keep. For 0 volts you are getting that current is 0 only, right? You have to take 0.1 volt you have to apply. How much? 0.1, correct? 0.1 you have to apply, 0.1 volts you have to apply. How much you are getting? 1 point or 0.3, right? 0.3 microfarad. Next VBE, keep on 0.2 you have to take, 0.4 you are getting. Next 0.3 you are taking, 0.3, 1.2 you are getting. Now you have to see 0.4, 0.4 you have to take, 6.5, and you have to apply the 0.5. How much you have to get? It is 16.5 for VC is constant. Similarly, now you take that this input voltage you have to remove. Now you have to set the output voltage. How, where we have to keep? Wherever the collector is there. So where collector is there, collector is here, correct? So now you have to keep this collector, now switch on it, right? Now you VCE you have to set it. How much you have to set it? The last time 0, now this time you have to apply 0.5 you have to apply. 0.5, 0.5 you have to apply, 0.5. Clear? So once you have to set, don't rotate it, fix it. Now you close this one. Now the positive, again you are going to the diagram. So what is our diagram? This VCE I am connected at VBE side you have to connect. So where it is VBE? This positive terminal, this positive terminal you have to connect it. Where it is base is there, there you have to connect. Now you adjust it. Similarly, you have to see the observations. What are the observations? Once apply the 0, you able to see 0 only you are getting. Now you have to rotate it. Rotate. How much? 0.1 you have to apply. 0.1. 0.1 you are getting the 0.1 also. Now 0.2, 0.2 you have to apply, it is 0.4. 0.3 you have to apply, 0.6 it is coming. 0.4 you have to apply, 3.4 it is coming. 0.5, 6, 5 and so on you have to apply, you are getting that value. So those values you have to see based on similar procedure you have to do. VC is equal to 1 volt you have to keep the constant and changing the with the steps of VBE and noting the IB, and then you have to draw the characteristics curve VBE versus IB. So the curve will come like this whenever the VCE is there. So VCE for 0, this is the curve will come like this. VC is equal to 0.5, that curve will come like this. VC is equal to 1 volt, that curve will come like this. So you find the slopes. So the slope will get the delta IB is divided by delta VBA. For you reciprocal of the slope, you will get the resistance delta VBA is divided by delta IB. So that is nothing but a input impedance. Which one it is? Input impedance of BJT. Clear? So that input impedance, what is the unit of the input impedance? Ohms. How much it is coming? That input impedance you have to write here. This is the result of the input impedance. Clear? So this is the characteristics of a input characteristics of a BJT. Please share, subscribe and like our YouTube channel. Thank you.